We're recording.
Okay. Hi, this is Mark Lawrence. I'm the Regional Planning Director. This is the second night, and hopefully tonight will go a lot smoother. We have a new camera. We have a new microphone. We've got content that's a little more confined, although we do have a robot. We've got a mock-up board of some pneumatics. Hopefully we'll cover a lot of topics. So the first one is electrical wiring, pneumatics. Second one, we're going to tie in Jed Rutherford, who's actually the representative from National Instruments, who has been helping us for, gosh, how long have we been using the Serio? This is the 4th year. So Jed's been doing this 4 years now. And then finally, at the end of the day, we have Adina coming up to talk about funding. And I don't want you guys cutting out when we do funding, because I'm going to come up and say a few words to sort of kick that off, because we're getting to be a very, very big program, and funding is getting to be a real burden for the program as a whole. So we're going to talk about that. So with that, I'm going to introduce the Robettes. They're going to do about 45, 50 minutes on pneumatics and electrical wiring, and then we'll just move on from there. Take it away.
Okay. Thank you. Hi, I'm Mary Schubert, and I'm one of the captains of the Robettes. I'm Racine Hansen. I'm also a captain of the Robettes, and we're here to present on electrical basics. Okay, so the first thing we're going to talk about is tools of the trade. And for this season, there's going to be a lot of different components and tools that you're going to need to know how to use to make the season run smoothly. And I'll just give you a brief list. So the wire, you want to make sure you know the differences between the different wire gauges. There's 8, 12, 14, and 18. A wire stripper, a wire cutter, pliers, soldering iron, and a desoldering iron, connectors, a crimper, and a multimeter, and heat shrinking gun. All right, some wire basics. When using wire, it's important to remember that the smaller the wire gauge actually means that the wire is bigger. So like an 8-gauge wire is a lot bigger than like a 14-gauge wire. It's extremely important that everyone knows how to cut and strip wires, because you'll be doing a lot of that in the season. And cutting wires is pretty simple. All you have to do is use a wire cutter, and stripping wires basically just takes the insulation off the wire. So now we'll give an example of soldering. Can you go with the camera? Yeah. It's important to always have your hair tied back so that you never burn your hair. It smells really bad and it's not good. Can you see that? Great, yeah. Okay. All right, so you just want to put the soldering iron on the wire to heat it up, and then bring the solder to it and put it on the wire to melt it, like so. And then do the other side. And solder is a metal alloy, and it is like a pretty permanent form of connecting two wires so that the electricity can flow through it. And at the end, it doesn't come off. Oh, right. Okay, good. All right, so good. So next we're going to talk about connectors. Yeah. All right, well, in the picture we have 4 different types of connectors, which are other ways of connecting wires other than soldering. We have pictured a spade connector, a female connector, ring connector, and a PWM case. And they're all used for different things. The spade and ring connectors can both be screwed down and with screws. And the female ones are plugged into different electrical components like spike relays. And they all, the wire the yellow insulation, it all comes down to wire, and the PWM actually has other, which stands for pulse width modulation, has like little pins that stick into it, and that's what you use for those to be wire connectors. And it's not as permanent as soldering. Okay, so a digital multimeter is used to measure current and resistance. Resistance is measured in ohms and current is measured in amps. And you want to always make sure when you're trying to find the resistance or the current that you set it higher than what you're actually going to use, so then you can find the correct value. All right, heat shrink is used to protect wires from any damage that might happen, and it usually covers different electrical connections, like when you solder, and it also protects the wires from shorting out onto any of the robot. And a heat gun is what you use to actually shrink the casing, the heat shrink, and it's just aimed at the heat shrink, and that's it. Kind of like a blow dryer. Yeah, it's like a blow dryer. But hotter. All right, so zip ties. When you go to organize your electrical board, it's important to use zip ties, or that's one option for keeping all the wires bundled together and organized. So you can just use a zip tie like you normally would and bundle it around the wires, so they look really nice. Okay, then this is just basic stuff, like you will be using Allen wrenches and screwdrivers throughout the build season. I mean, they are usually like a typically mechanical tool, but electrical teams also use them often. Okay, so listed is a kit of parts, and veteran teams will get a slightly different kit of parts than the rookie teams, because the rookie teams like get more supplies, and so you can just look at the list. All right, the battery is one of the most important parts of the robot. And just some tips for when handling the battery. Don't be really careful not to drop it, because that could make the battery be dead. And try not to hold it by the wires, because the wires could be pulled out since the battery is pretty heavy. And you want to use 8-gauge wire when connecting the robot to the battery. And you want to make sure this battery is in an easily accessible place on the robot so that you can take it out easily and switch batteries when they need to be charged. And you want to make sure you have to take really good care of the battery, because then it can have a long life. And if battery acid leaks, baking soda, if it helps it. Yeah. All right, so the 120 amp circuit breaker is the on-off switch, and it connects to the battery and the power distribution board. And it's called a circuit breaker because it interrupts the power flowing between the battery and the power distribution board. And so there's to turn it on, there's a black switch on it, and then the red button on the top is used to turn it off. Our power distribution board connects to the 120 amp circuit breaker with a red power wire, and it connects to, and they're both 8-gauge wire, and it connects to the battery with an 8-gauge black wire. And it basically just takes all the power from the battery and distributes it throughout the other electrical components in the robot. And listed on the PowerPoint are just the different amps, 20 amp circuit, or the amp circuit breakers on the power distribution board, and the kind of wires that you need to use to connect them to the different components on the robot. Okay, so there's two different colors for Jaguars. There's a black one, which is the newer one, and then a gray one. And a Jaguar is a speed modulator. It connects to either PWM or CAN interface. And it connects to either 20, 30, or 40 amp circuit breakers. And one of its unique features is that it can modulate between the speeds, so it doesn't have to go in full forward, full on or full backward mode. It can go in between. All right, and then if you choose to connect your Jaguars with CAN interface, it's important to remember that the first Jaguar on the CAN chain should always be black, and it doesn't matter what the second one is, that can be gray or black. And then you have to remember to put terminators on the first and last Jaguars in the chain. And if you look, the red and black screws are for the power wires, and then the green and the white one are for to connect to the motors. And it's really helpful to use CAN interface because then you can connect your limit switches and rotary encoders directly to the Jaguar instead of having to use a digital set card. Okay, so a spike is similar to a Jaguar, however, it cannot modulate between the speeds, so it either is like fully on or off or at rest. And it is also can be called a relay. A Victor is another speed modulator, and it is similar to the Jaguar in that it can control the robot's speed and not just send it into straight full forward or full back like the spike relay. But it has a visible muffin fan on the top, and it connects much like the Jaguar with the signal wires on one side. Or no, it has PWM and it's connected to a motor. Okay, so an energy chain can be used for organizational purposes or, and it helps like last year, or we didn't actually use it last year, but it could have been used last year for the elevator because it helps keep the wires together and not get caught when like an elevator moves up or down, or can be used for like various other things. And an energy chain like only moves in one direction. So the Serio actually pictured here is larger than the one that will be given in the kit of parts this year. The new Serio is much smaller and more compact, and takes up about half the room. A DB37 cable connects the Serio to the digital sidecar, and all the code goes into the Serio so that it can control the robot. So digital sidecar is used for most inputs and outputs. The PWMs on the right side are for speed controllers like servos and relays, and the ones on the left are for spike, and all connections are PWM. A servo is used to release mechanisms to be at a certain angle, and so with the camera, you can use that to help track use it with the game to track something on the field. And it's important, like over the years, we found that the power wire can slip out or wiggle out. So we found that if you hot glue it into place, it helps solve the problem. Okay. The radio is what yeah, it's like talks to the driver's station, and it controls the robot. But so some mounting tips. You can mount. You want to make sure that you don't mount things to any metal component to another, like the metal on the robot, because you don't want to short anything out. And you can mount things onto like plexiglass or like wood. And as far as organization goes, it's important to keep components on the robot close, electrical components on the robot close to the things that they're supposed to connect to, so that because then it's easier to know where they're going, and as well as when power wires are too long, it can decrease the power level that the wires can control. And you're not supposed to mount components directly to metal, because then it could cause the robot and the components to short out. For organization, you can choose to like run wires underneath, so you could drill holes and then run the wires underneath, so that on the top you just see where the wires go from one component to another. And you could also use a You could use zip ties or other things if you, yeah. And it's important to plan out your board ahead of time so that you know where everything's supposed to go and you're not confused when you are finally putting everything into the robot. And then to label things is also really helpful because then you know where all your wires are going when you need to fix anything that could be wrong. So safety is really important during the season and throughout like the competitions and everything. And it's important to make sure that you always have your hair tied back if you're dealing with any like mechanical or like for electrical if you're soldering or anything. And you also want to try to have your safety glasses on at all times and to not wear any have any loose articles that could get caught in anything. If you're soldering, it's also maybe a good idea to have a fan so that the person soldering doesn't get lightheaded, and you want to make sure it's not lead-based solder. And all bare wires, you want to make sure they're covered so nothing shorts out and nobody gets electrocuted. And then just some basic electrical safety. When working with the robot, make sure you remove the battery or turn the robot off before you start working on the robot so that nobody gets electrocuted or anything. And make sure you use a multimeter to test battery resistance so that it's not trying to power the robot too much and it's not overworking itself. And use a heat shrink, like Mary said. Yeah. All right. Well, does anybody have any questions? Yeah.
There's one question online that I see here. Is there a difference between the Jag and the Victor other than the price?
Yeah, actually, it's like the React.
So
what's it called?
the Jaguar can accept inputs from limit switches and from rotary encoders or potentiometers to help provide more direct feedback into the Jaguar instead of having to go through your digital sidecar.
But then isn't there like the difference with the curves? The response curves? Yeah, like with the Jaguar you have a linear response curve when you are driving the robot so that it works a lot better in the like shorter range of motion, and then but the Victor has like a cubed curve, so it doesn't work nearly as well as the Jaguar does in the short range.
Is one more robust than the other?
Well, the Victor is actually a lot smaller than the Jaguar. So if you're like trying to,
I think the bottom line on that question is one more robust than the other. You end up frying a lot of them anyway.
Yeah.
Because you end up putting a lot of current through those, and gosh, they just especially we talked about this last week. It's really easy to get metal pieces and shavings inside those components, and because you're putting so much electricity, it's going to short them out really easy. So, as we said last week, when you're building, if you're doing any cutting or drilling on the robot, make sure they're covered up. But you know what? Try not to do that because you're almost guaranteed to ruin one of those devices. So I got another question.
Yeah.
Talk about the placement of the master cutout switch. The one that goes between the battery and the power distribution.
oh, okay.
And what the inspectors look for.
120 amp circuit breaker. Is that just
That's
switch? Okay.
So
So you want to make sure that that is at a visible part on the robot so that they can this probably can be turned off like quickly and easily. And it doesn't take a lot of fidgeting around to do. It can just be, and if it isn't clear, you should probably label where it is on the robot.
So if people on the field try to put it away from moving mechanisms too. They don't have to reach under their arm while it's swinging wildly to turn off the robot. And I have actually seen a robot inadvertently turn itself off by an arm moving.
I have allowed you guys to unmute yourselves and ask questions if you want to. Any questions? All right.
Okay. We're going to change gears now, and we're going to switch to pneumatics.